Hello and welcome back to the video lessons for outcome 30.7c, where again we are continuing to look at sinusoidal functions. Today though we are going to switch from simply looking at graphs to start looking at equations and those characteristics based on them. Again, that will all lead towards those level 2 questions where we are matching up which graph is which one. So again, today our goal is going to be looking at characteristics from the graphs of sinusoidal functions from their equation, which, in my opinion, is more difficult than the graphs. So we're going to start just by looking at what do all these things mean. So when we have sinusoidal functions, remembering from the beginning that every graph is both a sine and a cosine graph at the same time, just depends on where we start. So for this graph that goes between 6 and negative 4, 6 plus negative 4 divided by 2, 2 divided by 2, that's 1. My midline is at 1. The graph is starting on the midline. I would say this is a sine graph, just simply based on where I have it starting. But you know what? If I also started here, that would be a sine graph. Now I could choose to start looking at it here on these maximums. If I chose that, then my graph becomes a cosine graph, based on where I choose to start looking first. The other thing I want you guys to recall is just numbers down there mean that this is a radian graph. I can do the same thing over here on this. Second graph is going between negative 3 and 7. So my midline is at 2. So if I choose to start here on these humps, that would make a graph cosine. However, I can choose to start on the humps where it's going up first. That would make them sine graphs, just based on where I choose to look first. Again, noticing those degree symbols, this is a degree equation or function. So again, you can see that when I write the equations, y equals a for both. Then it's either sine or cosine, then they say b, same spot. And then it goes x minus c in brackets, same thing there, and then plus d. They look exactly the same. A, B, C, and D do the same thing no matter it's sine or cosine. So that kind of makes our life a little bit easier. And at this point, we're going to start going through what all those things mean. A, B, C, D. So A is the easiest. A stands for amplitude. So whatever your starting number is the amplitude always. Just like we learned the very first day, amplitudes are always positive. If you get a negative answer, this is basically something called an absolute value. It just says it makes a negative turn positive. You can never have a negative amplitude. It will always be positive. So example. It says arrange these functions in order from least amplitude to greatest. So my first number is my amplitude. Amp is 3 here. My amp is 4 here. My amp is 2 here. Even if I were to insert a little negative in there, my amplitude would be positive 2 still. So from least to greatest, my least one is C. That is less than the next one, which is A, which is less than the next one, which is B. There's my ranking. So A is the easiest. We're going to get progressively harder as we go through A, B, C, D. The next easiest one is D. So notice how I say midline. Midline, it's the D value. Okay? So the last value is your midline. So if you want to find the max or the min for that, you take the midline and you add and subtract the amplitude to figure that out. So all I'm going to do is an example of showing you how to find the midline and then how to find the max and min based off of that. So I said determine the equation of the midline, the amplitude, and the range. So let's start with amplitude. We just learned amplitude. Amplitude is the first, right? Your A value. So amp is 8. And my amp is 6. There. The next thing we learned was the midline, right? Midline is the D value, the last one. So 5. So Y equals 5. Over here, my midline, again, mid, the D value is -7. So Y equals -7. Now, we want to find the range. To find the range, right, your range is always the minimum first, maximum second. How am I going to find those things? So the first thing I do is I'm just going to draw a quick sketch because I find that helps me out. This is at Y equals 5. Now, sinusoidal functions, right, curve up, curve down. I have to go up my amplitude, I got to add 8, and I got to go down my amplitude, I got to subtract 8. So my max is going to be 5 plus 8. My min is going to be 5 subtract 8, which is -3. So my range is from -3 to 13. Same thing over here, I draw a quick little sketch. This is Y equals -7. I do have to go up 6, and I do have to go down 6. So my max is going to be -7 plus 6, -1. My min is going to be -7 subtract 6, which is -13. So -13 to -1 is that range. Okay. Now the next one, a little bit more difficult, is B. B is not the period. It's how we determine how many cycles are in 360 or 2 pi. So when you have a degree question, you need to remember that you take 360 and divide it by your B value. And if you have a radian question, you will take 2 pi and divide it by your B value. So the question then becomes, how do you know what to try? So what if I make a couple of equations here, just to kind of show you what I mean? Where is the best spot for this? Sorry, 1 second, I just want to see what I got here. Okay. So then to figure out how, I'm just going to do, again, a couple examples here just to show you. Got it all set up here now how I want it. So basically, it's always the number in the bracket that's going to tell you if it's a radian or a degree question. So this one has no bracket. So you get to choose. Radian or degree. Up to you. Here in the brackets, it's a radian. You have to use 2 pi divided by b. Here in the brackets, it is a degree. So this is a degree question for sure. You have to use 360. There's no deciding there. You have to. So let's do a couple examples to determine the period of each. So the first one, there's no brackets. You decide degree or radian. I will show you both, and you can decide which one you like better. So degree is 360, radian is 2 pi. My b value is 4. So 360 divided by 4 is a 90-degree period. 2 pi divided by 4, well, 2 and 4 both reduce. 2 divided by 2 is 1, 4 divided by 2 is 2. I get 1 pi over 2, which whichever one you like better. Again, there's no brackets, so a degree or a radian. I'll show you both. You can decide which one you like better. 360 divided by 0.25 or 2 pi divided by 0.25. So when you divide that out, 360 divided by 0.25 is 1,440. 2 divided by 0.25, again, just leave the pi out there and just worry about the numbers. So 2 divided by 0.25 is 8, and keep the pi. Whatever one you like better. This question in the brackets is a degree, so it's only 360. And my b value is 2. 360 divided by 2 is 180 degree period. So if I'm ranking them from least to greatest, the smallest is 90. The next is 180. The next is 1,440. So that's how you find period. One more now. We have done A, we've done B, we've done D. Last but not least, it is C. C tells you a horizontal translation. C is the number in the brackets with an opposite sign. Just like you would have done with parabolas in grade 11 and slope point form in grade 10, when you find things in brackets, you take the opposite sign. So here's one example. So it's y equals 3 sine 2x minus 4. So my value is plus 4. Plus means I'm going to move to the right. So it's a horizontal translation. I'm going to go right 4. I'm going to move to the right 4. In the brackets is a negative 180, so positive 180. Positive means to the right. I am going to move to the right 180 degrees. In the brackets is a positive, so that is like negative 30. Negative is left, so I am moving to the left 30 degrees. So right now you're going to go to practice 3 and just practice figuring out A, B, C, and D for some different equations and what they do.